All right, I'm here with David Deutsch. David, thank you for joining me.
Thank you for having me. Good afternoon.
Good afternoon indeed. So, I want to talk about the universal constructor, which is a theoretical machine that can cause any physical transformation that can possibly be caused. Now, why is understanding the universal constructor important to understanding the nature of reality rather than it being merely an engineering curiosity?
Yes, it's more than just a curiosity, by the way. The idea of the universal constructor is basically ancient. It's like began with the idea in antiquity of a cornucopia, which was a thing that produced an endless supply of whatever food you would like, delicious food. But then pretty soon people began to think about a machine that could produce anything you like. And this has been explored in science fiction and so on. So I don't think it's just a curiosity engineering wise. It would be a dramatic and important innovation. But you ask about what is its connection with fundamental physics. It is basically a generalization of the idea of universal computation. And universal computation, as conceived of by Babbage and Lovelace and then by Turing, is really the only way to understand what computation actually is. A non-universal theory of computation wouldn't be a theory of computation at all. That would be just a theory of engineering. So the theory of universal computation, which I then sort of brought into the quantum era by developing the theory of the universal quantum computer, is the assertion that such a thing can exist, is an assertion about the laws of physics. The laws of physics are such that there is a single machine that can mimic the computational power of any other machine to arbitrary accuracy. And all that you have to give it is fast hardware and memory. Now, the universal constructor comes in here because that universality is not the only one that could exist. And in fact, I think it is not the only one that does exist. There's also the question of not just performing any computation, but performing any transformation of physical objects. And not if given enough memory and so on, but if given only knowledge. Because if there's something you have to give it other than knowledge, which it itself couldn't provide, then it's not universal. So it has a similar but different logic from a universal computer, and its relationship with physics is a generalization of that of the universal computer.
Now, you wrote in the foundational paper on constructor theory that the possible existence of a universal constructor might be proved from independently motivated constructor theoretic principles. Now, I know it's still early, but I wonder, have you made any progress of, if not the proof itself, but what that proof might look like since the constructor theory program began?
Yes, I have. In fact, I have been struggling to complete a paper on the universal constructor from within constructor theory. And I think I have a proof, but it is rather cumbersome and clunky, and parts of it are not intuitively compelling. So as I say, I've been struggling with trying to complete that paper for some time now, but I have done enough to convince myself that, to put this in a mathematical way, it is a theorem of constructor theory that the universal constructor exists. That is a machine which can be programmed to perform any transformation that any other machine can be programmed to perform.
Let's say, hypothetically, if this proof doesn't pan out, or if it turned out as you were working towards this proof that such a machine is possible, that it turned out that actually a universal constructor is impossible to build. What might that tell us about the laws of physics? Now, I understand it's sort of depends on why the proof doesn't work. But I wonder if you have, right. So, but I wonder if you have any thoughts. For example, might it tell us that the principle of interoperability is false or something along those lines?
Yes. So, as you say, what it would tell us depends on what exactly would go wrong and what would seem to be irreparable in the proof. I think whatever it is that went wrong, it would be interesting. It would tell us that there isn't, after all, the apparent connection between understanding the world and controlling it that there appears to be. So it could be that if there is no machine that can be given just knowledge to then perform any given transformation, then, well, I can't quite imagine exactly what it would imply. But if there is something that you can't program a machine to build, then that really means that there is something that can't be built. And if there's something that can exist but can't be built, then that means that it might mean that there's a resource in nature that is finite and not replenishable. Not just a resource like negative entropy, but a resource like, let's say, a monopole, a magnetic monopole. We think there aren't any, but suppose that we're wrong about that, and suppose that there is exactly one magnetic monopole, then that would mean that any machine that included a magnetic monopole in its design, essentially, so that it couldn't perform its function without the magnetic monopole, then that would mean that that particular machine could perform a task that no other machine can perform. And, if the magnetic monopole falls out and rolls across the floor and you can't find it, then the task can't be performed at all. And if you can find it, it can only be performed once by that machine, and there'll be a maximum speed at which it can go, and so on. So that's the kind of thing it would say. It would be a sort of de-universalization of our fundamental understanding of the universe. We tend to think, when thinking about more and more fundamental things, that the laws about fundamental things are going to not refer to specific objects. Like, there isn't just a law that applies to the Eiffel Tower. There are laws that apply to iron structures and to structures built in gravity and so on, so that any truth about the physics or engineering of the Eiffel Tower can be expressed in terms that do not refer to the Eiffel Tower. But that might be false. And if it's false, then it would definitely mean that there's no universal constructor.
So if a universal constructor is possible to build, then presumably people are entities that can build them with the requisite knowledge, as you were kind of alluding to. So then why would a person not be considered a universal constructor, since every transformation that a universal constructor can cause, a person plus a universal constructor could also cause?
Yes, indeed. Well, the answer is imperfection. So a constructor is actually a limiting case, an unphysical limiting case of real physical objects. So there is no such thing as literally a constructor for converting hydrogen and oxygen into water, for example. You can perform that with 99% accuracy or 99.9% accuracy, but not with 100% accuracy and 100% reliability. There's always a probability that some of it will escape and so on. And for any given machine that can convert hydrogen and oxygen into water imperfectly, there's another machine that one could build that would build it less imperfectly. But there is no machine that could build it with absolute perfection. Now, you can regard a human being as a highly imperfect universal constructor, in that, given enough knowledge, a person could build a universal constructor that's better than itself. And in fact, that's the secret to the proof and to the theory of the universal constructor as I see it. But the thing is, suppose you need more memory than the brain has capacity for. Then, unlike with a computer, it's not a trivial thing, just, oh, well, we'll give it more memory. With the universal constructor, you'll have to say, oh, well, we'll have to tell it how to make that memory. And so we would have to be given the program for making enough memory to do the task of a universal constructor and so on. And then once we're given all that massive amount of information to do all that, there might not be time in a human lifetime to do that. So therefore, we'd have to be given a program that would extend the human lifetime and so on. So you see that the degree to which a human is a universal constructor, well, it's rather a Pickwickian sense, because it's so highly impractical and would require so much knowledge that we do not currently have, that, and if we did have it, we could do the universal constructor thing much more easily, that it's, for most purposes, not useful to consider humans as a universal constructor, or a human at any rate. It could be that humans as a whole are. There's also the fact that neither a human nor the set of all humans is obedient. A universal constructor has to be perfectly obedient, and people and collections of people are disobedient. And in fact, disobedience is necessary for their more important functionality of explanatory universality.
Have you given any thought to what the economic implications might be if and when humans commodify the universal constructor?
This has been studied by many people before. I think people have had somewhat the wrong idea of what a universal constructor will look like, but it doesn't make any difference for thinking about economic issues. I think one thing that many people may have got wrong is that the universal constructor won't be as sudden a change, like a singularity. It won't be a singularity, because although it is true that a universal constructor can be programmed to build two more, and each one of those can be programmed to build two more, and so on. First of all, this will at first be done rather inefficiently, just as, the very first one will have to be built by humans and inefficiently and so on. And secondly, the issue of ownership and value of raw materials does not go away once the issue of human effort goes away. The human effort will go away, apart from the effort of programming universal constructors, but that's non-trivial. So people will be writing programs in effect. I mean, that doesn't mean that they'll be doing the same sort of thing as programmers do today. It's more like they'll be doing the same sort of thing that scientists and engineers do today. Mostly, they make designs in a computer. But then there will still be the issues. If you want to convert, I always give this example, if you want to convert Phobos and Deimos into busts of Napoleon, you'll run into the problem that someone else wants to convert them into busts of somebody else. And this issue, we know how to resolve issues like that. It's with ownership and private property and capitalism, and also a regulatory framework that's based on the rule of law and that kind of thing. So we know how to do that. But it does mean that you can't just design a thing and have it built. It will still cost something. And how do you make money in a society with universal constructors? Well, you make money the same way that engineers do today, by programming computers.